Hello everyone, welcome to Kwiation Engineering YouTube channel. All right, so today I start module 11 lesson series. So this is the first one, part 1. So module 11 is a very big lesson, very big module. So you have to write phase for 140 questions. So you need to take at least to take the 75, at least 128 or something you need to take. You need to pass, you must correct the answers. And this modules is about talking about the systems. Actually, this is the basic way. It's not like type training, but you must learn this one. So I'm going to start because so many my subscribers, they asked me to do this module. Okay, so as of my knowledge and how I make the presentation, so I try to do most simplest way for you to understand module 11. Okay, so let's start from today, module 11 lesson. So whatever the days I can, I will prepare the presentations, and I will record these videos for you guys. All right, because I cannot promise, okay, I will do is 1 week, 1 week, 1 week. So because it's take time for me, because I'm also working. All right, so don't worry, I will do my best to upload these videos for you guys. All right, so and also, if you still not subscribed Kwiation Engineering, please subscribe. Please share these videos with your friends and your relatives, anyone who like to learn about aircraft maintenance. All right, okay, so okay, let's go to the lesson. All right. Okay, so today I'm going to teach module 11, aeroplane aerodynamics and flight controls, part number 1. Okay, all right. Let's see what is the content in here. In this video, the content is introduction. I will talk about the longitudinal axis, lateral axis, and vertical axis, and then the flight controls like ailerons, flaperons, spoilers in roll function, and the elevators, stabilizers, variable incidence stabilizers, it means like trimmable horizontal stabilizer or THS, and canards, and Elevons, ruddervators, and also finally the dash roll. Okay, actually this is the very basic. If you watch the typewriting videos, this one has very advanced level. All right, okay. So let's go to the first one, introduction. Okay, an aircraft is made to fly in a straight and steady way. Okay, so if something like wind push it, the aircraft can go back to its normal flying position by itself. The pilot does not need to do anything for this happen. Okay, but if the pilot wants to turn or move the aircraft, okay, but if the pilot want to turn or move the aircraft to any area, any direction, they must put the controls. Okay, so this is because the aircraft wants to stay steady, so the pilot needs to use force to make it move. It means if the aircraft is flying, it's just fly, but if you want to move to another place or some another direction, so you must use the controls, right? So an aircraft can move in 3 ways in the air, right? The aircraft can move in 3 ways. Okay, what? Pitch, the nose up and down. Nose up and down mean the pitch. And the roll means the wings goes up and the other goes down. Okay, example, the wings is like this, wings goes up and wings goes down, other wings goes down like this. This is called rolling action. And next one, the yo means the nose turn left and right. Here this is the nose can turn left or right. Okay, that is the 3 ways the aircraft can move. So all these movements happen around the point in the aircraft called center of gravity. So all, I mean pitch, roll, yaw, all these things happen around this point. What is this point? Is called the center of gravity. So this is the balance point of the aircraft. Okay, this is the balance point of the aircraft. So in this lesson, we will learn about the parts and the systems that helps the pilot control the aircraft in the air. Okay, so actually I want to tell recently I saw some comments, some guy, this is the worst channel he saw. So actually I want to tell the guys who think like this. Okay, really I don't want to take a whiteboard background, and I don't want to teach something like this, something. I just, I'm just working hard for this kind of notes, because I'm also getting notes from my previous college. So I make this note as a simplest form for you guys. because these notes very hard to understand, some people very hard, but I'm trying for everyone can understand, so I'm trying to do it as very simplest form. And he said, I'm just only reading, I don't just no don't do some calculations or something like this. Okay, I'm agree for you guys, for this guy. And okay, I respect for you guys because he give me the comment. So the thing is, actually this channel I'm not doing to earn money, right? I'm just doing this channel to share my knowledge with you guys. So if you cannot take any knowledge from this channel, it's okay. I'm not forcing you to watch these videos. So up to you. If you want really knowledge about this, just use this channel. You can gain the knowledge and you can upgrade your knowledge from these guys. Don't see how we teach, right? You just take the knowledge, because I'm just writing, I'm just make my own notes, and then I just read from myself, because it's also kind of way the people can understand. Because example, I can teach from the board back, I will keep a board backside and I can teach, but I will talk, but you cannot understand. After 1 second, you cannot understand what did I tell. Okay, so but these forms, even I read the same thing in this the screen. You have, like, you hear my voice and also you see the word. So then you have two kind of things go to brain. So you will get more knowledge. Okay, all right. Sorry, I took your time for this description, because I saw some comment today, so that's why I don't care this kind of terms. But actually, thank you for you to give me this kind of comment, because I can upgrade. Okay, in future I will try my best, as you said. Okay, all right. Sorry for interruption. Okay, let's go to the lesson now. And now, okay, you can see this is the three axis. Okay, yaw axis, pitch axis, and the roll axis. Like example, sorry, so you can say yaw is happening under vertical axis, like directional stability, and roll action is happen under longitudinal axis, like the lateral stability. And the elevators, like pitch, happening in the lateral axis, like longitudinal stability. Okay, right. So you can get an idea from this picture, like primary surface controls are ailerons, elevators or stabilizers, and rudder. So airplane movement through the ailerons, it's happen rolling movement, and the elevator stabilizer used to do the pitch movement, and the rudder is used to do the yaw movement. And the axis of rotations roll happen in longitudinal, pitch on lateral, and yaw in vertical. And the type of stability, the aileron used to lateral stability, and elevator stabilizer used to longitudinal stability, and the rudder is used for directional stability. All right, so now let's go to the longitudinal roll axis. Okay, all right, the longitudinal axis is an imaginary line. Okay, in the aircraft, they don't make it they don't mark any line. Okay, so that is an imaginary line. So longitudinal axis is an imaginary line that goes through the aircraft from nose to tail. Okay, so you can see this aircraft, you see from the forward. So this longitudinal axis go through nose to tail. Here this is the nose, and is go on back to tail, right from the middle of the body, like a fuselage. So when the aircraft moves around this axis, when the aircraft is moves around this axis, it is called the roll. So this means one wing goes up and the other wing goes down, like when an aircraft turn or tilts sideways. You can see this is the steady way, normal altitudes. This is the longitudinal axis. When the roll happen, the aircraft can go like this. So in this time, this one is go down, this wing go down, and this wing go up. And you can see some shadow, right? So this wing goes up and this wing goes down. So this is called the rolling action. So this movement is controlled by the parts called ailerons. So rolling action controlled by the ailerons, which are on the back of each wing. Every wing has like in a back, in the trailing edge area, they have a ailerons. All right, so we can also call the longitudinal axis the roll action, because it controls rolling movement. So this is important for turning the aircraft left or right. So rolling actions very important to turn the aircraft left or right during flight, especially when changing directions smoothly. All right. Okay, now let's go to the lateral pitch axis. Okay, lateral pitch axis. Let's see. Okay, so when the lateral axis is an imaginary, so lateral axis also an imaginary line that goes side to side. Before one nose to tail, and now the side to side. So side to side is if you see the aircraft from the sideways, so this is the one side and the other side. So the line goes from one side to other. It means left to right or right to left. Okay, side to side from the wingtip to other this wingtip to other wingtip. So when the aircraft moves around the axis, when the aircraft moves around the axis is called pitch. It means this is the axis and the aircraft is moving like this. So this is called the pitch. So this means the nose of the aircraft goes up or down. So this movement is controlled by the elevator. So this movement is controlled by the elevator, so which is usually on the tail of the aircraft. So the elevators are on the tail of the aircraft. Okay, so we are also called the lateral axis of the pitch axis because it's controlled pitching movement. So pitching helps the aircraft to climb, go up, or descend, go down. So pitching movement helps to the aircraft go up or go down, descend or climb, all right, during flight. So the climb and dive pitch control affected by the elevator movements. You can see this is the aircraft. So when the elevators moves up or down, the aircraft goes nose up or nose down, all right. Now let's go to the vertical or yaw axis. Vertical or yaw axis. The vertical axis also an imaginary line that goes up and down. Okay, that goes up and down through the center of the aircraft. The vertical axis of an imaginary line that goes up and down through the center of the aircraft from top to bottom. So in this time, the vertical axis comes from top to bottom. So when you see the aircraft from the top, you can see this is the area. So this is the line is go from top to bottom. So when the aircraft moves around this axis is called the yaw. So the aircraft moves around the axis is called the yaw. It means you can see the aircraft moving left side or right side. Okay, that is called the yaw. Right. So this means the nose of the aircraft turns left or right, but the wings stay level. All right, so this movement is controlled by the rudder. So the yaw movement is controlled by the rudder, which is found on the tail fin. Here the tail, the fin, they have a rudder. So vertical stabilizer of the aircraft. So we also call the vertical axis the yaw axis because it controls yaw wing movement. So vertical axis is sometimes also called the normal axis. Remember, vertical axis sometimes we call as a normal axis. Okay, so yaw wing helps the aircraft turn left or right in a smooth way. So especially when flying in a curve area. So aircraft is going like a curve. This one has to be used. All right. Okay, so now let's go to the flight controls. Okay, flight controls. Yeah, every aircraft needs a special parts called flight control. Okay, why? Because we need the flight controls to control the aircraft. Okay, so the pilot can move it up, down, left, or right in the sky. These controls are divided into two main groups. What are they? Primary flight controls and secondary flight controls. So the primary flight controls for basic flying, these are the most important parts. They help the aircraft move in three ways, right? Primary flight controls are the one who using to control the roll, pitch, and yaw movements. Okay, so aileron found on the wings, they control roll. On wings ups, wing goes up, the other goes down. That is called ailerons used for the wings and used when turning the aircraft sideways. Okay, and the elevator we use for the pitch, found on the tail, is control the pitch, nose goes up or down, used when climbing or descending. And the rudder found in the vertical tail fin, for what we use for the yawing movement, nose turn left or right, used when turning the aircraft direction smoothly. So these three controls are used during every flight because these are the primary flight controls. From takeoff to landing, they help the pilot keep the aircraft flying straight, turning safely, or going up or down. So now the secondary flight controls, this one using for better handling. Okay, it means without secondary controls, the aircraft can fly, but without primary flight controls, the aircraft cannot fly. So these controls are not used all the time. Secondary flight controls not used in all the times, but they make flying easier, safer, and smoother. So they include, like you can see, what are the secondary flights? You like flaps, leading edge devices, spoilers, trim system. Let's see the flaps. Flaps located on the back of the wings. So they help the aircraft fly slower during takeoff and landing. Okay, what is the purpose? This helps to fly aircraft slower during takeoff and landing. And the leading edge devices found at the front of the wing, they help lift the aircraft at lower speeds. And the spoilers located on the top of the wings, they reduce the lift and slow down the aircraft quickly. So trim systems, they help the pilot keep the aircraft level without needing to hold pressure on the control at the time. All right, so these controls reduce the work the pilot has to do and improve flight safety, especially during takeoff and landing. All right. Okay, now let's see how the flight controls work, how the flight controls work. Okay, how the flight controls work. Okay, let's see. The flight controls work by changing the airflow over different part of the aircraft. Okay, flight controls work by changing the airflow over different part of the aircraft. This creates a force in opposite direction, which causes the air to rotate, turn around the center. Example, like moving the elevator up pushes the tail down. Example, if let's see, this is the elevator and this is the like nose. Okay, this is the nose. Like if the elevator up, then then the tail is go down and nose goes if the elevator up, nose also goes up. Okay. Okay, like I cannot show from the hand, like this. See, moving elevator up, tail down, and nose goes up. Moving the ailerons make one wing go down and the other go up, which cause rolling action. All right. Okay, so each control surfaces is built with limits. Okay, each control surfaces is built with limits. So the pilot can't move them too much. It means the flight controls cannot move according to the pilot's wish. Okay, so because this every controls have a limit. Okay, so this prevents the aircraft from being damaged or over control. Example, a good aircraft is designed by to be stable, right? Stays steady in the air and easy to fly. The pilot doesn't have to fly it with the control. Okay, so how the pilot uses the controls? Let's see, the pilot use a control column, also called a yoke or a stick. Yoke for the Boeing or a stick for the Airbus to move the ailerons and elevator. Foot pedals to control the rudder, remember. So these movements are sent to the aircraft control surfaces in two ways. First one, mechanical system uses cables, pulleys and rods. Okay, normally the small aircraft and all the aircraft, they use mechanical system and found in smaller or old aircraft. But the fly-by-wire system, second one, fly-by-wire system uses electrical system. Modern aircraft, Airbus and Boeing also, they uses electrical system and common in modern jets like Airbus. So both systems do the same job. They move the control surfaces to the aircraft response to the pilot's input. All right. Okay, now let's see the Boeing versus Airbus controls. The Boeing used traditional control column, a yoke, in front of the pilot. This gives classic feel and is connected directly to the or hydraulically. It's connected directly or hydraulically. Airbus uses side stick controller like a joystick on the side of the pilot seat. This is part of the fly-by-wire system using computers to send signals. So although they look different, both systems let the pilot control the aircraft safely and effectively. All right, so in this picture you can see these are the flaps. Okay, you can see the flaps and these are the spoilers, roll spoilers. Okay, and these are some 1 2 3, these are used for the speed brakes. Okay, and this is the rudder, these are the elevators, this is the trimmable THS, trimmable horizontal stabilizer, and all these spoilers we called as ground spoilers. And this is the ailerons and these are the slats, leading edge high lift devices, right? Slats. Okay, just go right. Okay, right, so you can see this one, fly-by-wire electrical wire is connected to the actuator. Then when the aircraft the pilot inputs some signal, then signal goes and this one works. And booster controls, okay, this one hydraulically or pneumatically pump. Okay, and this one is simple, used by the pulleys and cables and pulleys, right? Okay, so this is a secondary flight controls. You can see the flaps. Okay, here's the flaps. Okay, yeah, these are the secondary controls or secondary flight controls. You can see I will take a photo, video or something when I'm working, right? All right, so now let's go to the aileron. Yeah, ailerons help the aircraft to roll. Okay, as we discussed in before, ailerons help the aircraft to roll, tilt side by side. They work around the longitudinal axis. Remember, ailerons works around the longitudinal axis, which runs from the nose to tail of the aircraft, which the longitudinal axis runs from the nose to tail of the aircraft, and the rolling actions rolling actions happening around the longitudinal axis. So where are ailerons located? Okay, so ailerons are attached to the back outer edge, right, trailing edge of each wing. You can see, okay, these are the these are the ailerons. Okay, right, where ailerons are attached to the back outer edge of each wing, and there is one ailerons on each wing. Normal aircraft, they have one ailerons on each wing, and they move in opposite directions. Okay, one ailerons move up, other ailerons moves down. If one goes up, another goes down. How do they work? So when the pilot turn control wing or stick to the right, okay, if the aircraft want to turn to the right, the right ailerons goes up. Remember, if the aircraft want to turn to the right side, right ailerons goes up. This reduce lift on the right wing. Okay, lift on the right wing, and the left ailerons goes down. This increase the lift on the left wing. So result, the aircraft rolls tilt to the right. Okay, that is the way. So when the turning left happen the opposite way, how the left ailerons goes up and the right ailerons goes down. Okay, so these movements lets the aircraft turn or bank smoothly in the air. All right, so now let's go to the lift and chamber. Lift and chamber, when an ailerons goes up, it's flattens the wing shape, less chamber or less lift. When it goes down, it makes the wing more curved. Okay, when it goes down, the wing say more curved and more chamber. Because of more chamber, they have more lift. So this difference is lift between two things because the wing causes the aircraft to roll left or right. So ailerons in large aircraft, big aircraft often have two ailerons on each wing. Big aircraft has two ailerons on each wing, right? Like 777, Boeing 777, 380, they have two ailerons on each wings. So outboard ailerons near the wingtip used only at low speed. Remember, outboard ailerons, they use only for low speed, used only low speed and called low speed aileron. And inboard ailerons closer to the aircraft body behind the engines, right? So used at all speeds, called all speed ailerons. Just remember. So at high speed, the outboard ailerons are automatically lowered. At high speed, outboard ailerons automatically locked, so they don't move. This is done to protect the wings from stress. Okay, maybe this one can be a questions in your EASA examination, maybe, right? All right, so now the aileron reverses. So at very high speed, especially on the flexible wings, right? Very high speed, especially on the flexible wings, a dangerous conditions called aileron reversal can happen. So when the ailerons moves, instead of rolling the aircraft, the wing bend and does the opposite of what's intended. This can make the aircraft unstable. So that's why outboard ailerons are locked at high speed. At high speed, outboard ailerons lock because of these reasons, right? And only the inboard ailerons plus roll spoilers are used. Okay, sometimes roll spoilers also using. And now extra help at low speed. So at low speed, the aircraft responds more slowly. At low speed, aircraft responds more slowly. So to help roll the aircraft, both set of ailerons, inboard and outboard, both are used, work together, and roll spoilers also help with the rolling movement. All right, so these are the different types of ailerons installations. Okay, these are the ailerons, you can see is come to the edge. Okay, something like this. And the double ailerons configurations, these are the outboard ailerons, and this one inboard aileron. Okay, sorry, this is the inboard aileron, this one outboard aileron. Okay, at high speed, outboard ailerons will be locked for safety reason. Okay, now the ailerons controls, the way the pilot control the ailerons depend on the size of the aircraft. Okay, the way the pilot control the ailerons depend on the size of the aircraft. In small light aircraft, there are no computers or hydraulic systems. Okay, the pilot use muscle power. Pilot use the hand power, muscles power to move the control wheel or stick, and this movement is sent to the ailerons through the rod, cables, pulleys, and levers. In large aircraft, the ailerons are much heavier than facing a strong air forces. So the pilot cannot move by hand alone. So the aircraft use hydraulic system or servo system to help move the ailerons. Okay. In most modern aircraft, like the latest Airbuses or Boeing, digital flight controls like fly-by-wire they are using. So these systems send the pilot commands to the ailerons using electronic signals, not cables, right? Okay, so just go through this system. Okay, all right. Now let's go to the turn coordination. When the pilot moves the ailerons down on one wing. Okay, turn coordination. Let's see what is turn coordination. It means when the pilot moves the ailerons down on one wing, that wings goes up because it gets more lift. But this also makes more air drag. Okay, slow the wing. Because of this, the plane nose turns a little wrong way. This is called the adverse yaw. Adverse yaw. Okay, so adverse yaw is stronger when the plane is flying slow or when the ailerons moves a lot. Okay, so planes with short wings feels this more. To stop this, the pilot used the rudder pedals to turn the nose in the right direction. Okay, so it means because of this problem, pilot using the rudder pedal to turn the nose in the right directions. Okay, so when the flying slow, the pilot needs to push the rudder more. By pushing too much rudder can cause problems. Also, when the plane turns, it often goes down a bit, so the pilot pulls back on the control stick to keep the plane flying level. So using the ailerons, rudder and elevators together like this is called turn coordinations. This helps the plane turn smoothly without slipping or sliding. Okay, maybe you have a questions. What kind of controls using for turn coordination? What ailerons, rudder and elevator? Three. Okay. Right, you can see the adverse yaw, right? Adverse yaw. You can go through this picture, right? Turn coordination. You can see rudder reflex with the ailerons, okay? Right. Now let's go to the adverse yaw solution. So to compensate adverse yaw, constructors have came up with three possible solutions. What are the, actually not three, actually four possible solutions. What differential ailerons and fries type ailerons, couple ailerons and rudder and different, sorry, no, I wrong, right? This one should be three possible solutions, right? I write two, right? Differential variance, fish type variance, and couple variance and rudder. Let's see differential variance. With differential variance, when the pilots move the control wheel, the one ailerons goes up more than the other ailerons goes down. Okay, this is also one technique, right? It means when the pilot moves the control wheel, one ailerons goes up more than the ailerons goes down. It means the angle of the ailerons goes down is lower, less than the angle of the ailerons goes up. Okay, so this creates more drag on the wings that is going down, which helps stop the plane nose from turning the wrong way. This method reduces your adverse yaw but does not completely get rid of it. So now the frizz type ailerons. The frizz type ailerons works by having the ailerons that moves up pivot on the special hinge. This makes the front edge of the aileron stick out into the airflow and create drag. So this extra drag on the wing with the race ailerons has balanced the drags from the other wing's lowered aileron. So because of this, adverse yaw is reduced and the plane turns more smoothly. Okay, now let's see the couple ailerons and rudders. Coupled ailerons and rudders. So in this system, the ailerons and rudder controls are linked together. Okay, couple ailerons and rudder in this system. Aileron rudders are controls are linked together. So when the pilot moves the ailerons and roll the plane, special spring also moves the rudder automatically. So this helps fix adverse yaw by turning the nose in the right directions without the pilot need to move the rudder pedals, and the pilot can still control the rudder pedals separately if needed and can override the automatic movements. All right. Okay. So you can go through these pictures. You can see the fries type ailerons here. Okay, airflow is go on from here, right? This area can move down. Okay, you can see the drag is happening here, right? And this one, the rudder ailerons interconnecting spring, rudder aileron interconnecting spring. And this one is differential ailerons, right? Differential ailerons, all right? Okay. Now let's go to the flaperons. Flaperons are control surfaces on the wings that do two jobs at once. Okay, flaperons are control surfaces on the wings that do two jobs at once. The first one, control roll, like ailerons. When the pilot wants to turn left or right, the flaperons move in the opposite direction. So one goes up and the other goes down. Okay, so just like regular ailerons, this make the plane tilt or roll to the left or right and act like a flap. So the flaperon control rolling, and also it as also act like a flap. Like sometimes the pilot needs to slow down the plane, and especially during takeoff and landing. So to do this, both flaperons can move down together to increase the lift and drag. Like regular flaps, this helps the plane fly slower safely. So how does the pilot control flaperons? How does the pilot control flaperons? The pilot has two separate controls. one for rolling the plane like ailerons, and one for lowering and raise up the flaps. So a device called a mixture combines these two controls and moves the flaperons in right way depending on what the pilot wants. Okay. So for example, like if the pilots want to turn right, the mixture moves the flaperons like ailerons, one up or one down. And if the pilots lower the flap, the mixture lower both flaperons evenly. And if the pilot does both at the same time, turn and flap, the mixture mixtures these movements properly. All right. Now let's go. So why use flaperons? Why we use flaperons? Okay, you can see the flaperons. They save space and weight. Actually, the flaperons, they do two jobs from one component. So why they save space and weights? Because one set of servers does two jobs, right? And they are useful on smaller light aircraft where having separate flaps and ailerons might be difficult. Okay. Okay, now let's go to the spoilers in roll functions. Spoilers in roll functions. Spoilers are flat panels on the top surface of the wings. Okay, spoilers are flat panels. Spoilers are flat panels on the top surface of the wings of many big and fast aircraft. When not used, spoilers lie flat and smooth on the wing. When the spoilers we don't use, it lie flat and smooth on the wing. And when needed, spoilers lift up into the airflow and break the smooth air, which reduces lift on that part of the wing. All right. Okay, so what do spoilers do? What do spoilers do? Let's see, spoilers have two main jobs. What are the two main jobs? Reduce the lift to slow down the plane and help the plane to roll. Okay, they have two jobs. What? Reduce the lift to slow down the plane and also helps the plane to roll. Like let's say reduce the lift to slow down the plane, called speed brakes, act like a speed brakes and ground brakes, ground spoilers, and help the plane to roll by working together with the ailerons, called roll spoilers. Okay, and next, how do roll spoilers help roll? How do roll spoilers help roll? When the pilot turns the control wheel to roll, the ailerons on one wing moves up, reduce lift. At the same time, some spoilers on that same wing also lift up, which further reduce lift on that wing. Okay, that is the way they help. So the spoilers on the other wing stay flat and smooth. Remember it. Okay, that is the way the spoilers helps to rolling action. Okay, so this helps the plane roll faster and more smoothly, especially on high speed. Okay. Right. Now the spoilers has different speeds. At high speed, spoilers are very effective for rolling. So sometimes the plane use only spoilers to roll without using the ailerons. Okay. It means that at high speed, spoilers very like effective, very effective. Because of this thing, sometimes the pilots, they use only spoilers. Okay. Spoilers to roll the aircraft. At low speed, the both ailerons and spoilers work together for rolling. Number of spoilers. Large aircraft usually have 6 or more spoiler panels on each wing. Not all spoilers are used for rolling. Some are only for slowing the plane down, speed brakes or ground spoilers, right? And how are roll spoilers controlled? Spoilers control is linked to the ailerons controls and works automatically. And all the planes, this is done by mechanical systems like mixtures. And on the modern planes, control is done by fly-by-wire computers that decide which spoilers to lift based on the pilot's input. All right. Okay. You can see, yeah, you see this ailerons goes down, then the spoilers also goes down. Okay. Right. No, sorry. Yeah. Okay. You can see this one. Sorry. The flaps, ailerons goes up, and the one of the spoiler is also goes up to reduce the lift. Okay. Right, roll spoiler function. Now let's go to the elevators. Right. The elevator is very important control surface that moves the plane's nose up and down. We discussed in earlier, right? Elevator is very important control surface that moves the plane's nose up and down. So it controls the plane movements around the lateral axis. Okay, this one control the plane around the lateral axis. If the flying is faced for the like this, and the lateral axis like this. Okay, so which goes from one tip wing tip to the other, side to side. So where is the elevator? The elevator is attached to the back side of the horizontal stabilizer. Okay, the elevator is attached to the back side of the horizontal stabilizer, the small wing at tail. Okay, and this usually covers most or all of the stabilizer width. So how does it work? The pilot moves the control yoke or stick forward or backward to move the elevator. right? So the pilot moves the control yoke. The pilots move control yoke or stick forward or backward to move the elevator. Moving the stick back, pulling makes the elevator goes up. Okay, if you pull, elevator goes up, and the back, which causes the plane nose to pitch up, go up. Moving the stick forward, it means pushing, makes the elevator goes down, and the back, which causes the plane nose to pitch down or go down. Okay, why is it positions at a tail? The elevator is far from the plane center of gravity, so it has more leverage. Okay, why is positioned as a tail? Because the elevator has far from the center of gravity, and so it has more leverage. This means a small movement of the elevator can cause a bigger change of the aircraft pitch, plane's pitch. So how is elevator movements controlled? In small airplanes, cables, pulleys, and rods connect to the control yoke to the elevator. Large and fast planes use hydraulic systems to help move the elevator because it takes a lot of force. And the modern aircraft fly-by-wire use combination of electrical signals and hydraulic to control the elevator. Right. So how the elevator changes the lift? The horizontal stabilizer usually creates a downward force. Okay. How the elevator changes lift? The horizontal stabilizer usually creates a downward force or negative lift to keep the plane balanced. When the elevator moves up, it increases this downward force on the tail, pushing the tail down and make the nose go up. Okay. So when the elevator moves down, the opposite thing happens. So special note for large jets. Large jets often have two elevators working together. The effective is stronger at high speed. So the manufacturers put in systems like elevator-free mechanism from Boeing planes or limit elevator movements at high speed to protect the aircraft from damage. Okay. Right, you can see this is the nose up, downward aerodynamic force, tail down. Okay, if the elevator goes up, nose up. Okay, just remember. All right. Now the stabilators. Yeah. Okay, the stabilator is a special type of tail control surface. Stabilizer is a special type of tail control surface. It look like a horizontal stabilator. Stabilizers look like a horizontal stabilizer, but instead of just having a moving elevator on the back, the whole surface moves. Okay, it means like the stabilizer, they have an elevator, but stabilator means all the stabilator is moving. Okay, so it pivots, rotates from the center like a seesaw, and when the pilot pulls back on the control stick, the back of the stabilator goes up and the nose of the planes goes up. Okay, same scenario like a elevator. So when the pilot pushes forward, the back goes down and the nose goes down. So why use stabilator? Because the whole surface moves, it is very powerful and can control the pitch of the aircraft quickly. But this also makes it very sensitive. Even small movements can cause big changes. Okay, so extra parts are added to make it safer and easier to control, like anti-servo tabs. We use anti-servo tabs, like these are small surface on the back edge of the stabilizers, and they move in the same directions. Anti-servo tabs, they move in the same directions as the stabilator, not opposite like trim tabs. Okay, and this makes it harder to move. Okay, so anti-servo tabs are very harder to move, so the pilot doesn't over control the plane, and it helps the pilot feel more resistance, which gives better control feeling. And next, the balance weight, to stop the stabilator from shaking. To stop the stabilator from shaking or moving too much in strong wind, balance weight is added, and this weight is placed in front of the pivot point center hinge, and it helps keep the stabilator steady during flight. And other names of stabilizers like all flying tail, plane or slap tail, like this. So these names means the same thing. The entire horizontal surface moves at just the back part. Okay, you can see this is the stabilator, the whole area is moving, right? Okay, now let's go to the variable incidence stabilizers, trimmable horizontal stabilizer or THS. Let's see what is it. The variable incidence stabilizer or THS is a special horizontal stabilizer that can change its angle, THS. So this helps the aircraft stay level without the pivoting having to constantly pull or push the control stick. It's mainly used for long-term pitch changes, like during like long climbs or changing weight balance, center of gravity or C of G. So why is it needed? Why THS needed? So elevators are great for quick pitch changes. Like elevators are great for quick pitch changes. but they are not good for holding the nose up or down for a long time. Okay, from the elevators, this one cannot hold it nose up or nose down for a long time. If the center of gravity shift, for example, fuel is burned and the weight moves backwards, the plane might try to pitch down. So instead of the pivoting pulling the stick the whole time, the THS is adjusted so the plane stay level on its own. So this reduces the pilot workload and keeps the flight smooth. Okay, that is the purpose. So how does it work? The front leading edge of the stabilizer is connected to the screw jack, a mechanical arm that moves up and down. It is inside the tail cone. Okay, so the back of the stabilizer stayed fixed, like stabilizer. The back is fixed and the front area is moving, right? It's fixed. So when the front moves, the angle of the whole stabilizer changes. This changes how much lift the stabilizer makes, which control the pitch of the aircraft. The screw jack is usually powered by hydraulics, but controlled by electrical signals from the pilot or autopilot. So modes of operations, how it works in different situations. Manual trim, the pilot adjusts the THS using buttons or switches on the control wheel. And alternate trim, backup mode, so used in emergencies, it bypasses the computers and controls the screw jacks directly. And the auto trim, the computer automatically adjusts the THS during flight based on aircraft behavior. And Mach or speed trim automatically adjusts the THS when the speed changes and center of pressure moves due to changing airflow over the wings. All right, so example, let's say the aircraft is flying long distance. As fuel is used, the aircraft weight shift backward like center of gravity moves. So this makes the nose want to drop. Instead of pilot pulling the stick constantly, the THS is trimmed to raise the nose slightly and the aircraft stays level. No elevator input is needed. Okay. All right, so that is called the trimmable horizontal stabilizer. Okay, you can see the angle here they marked. Okay, and here is the jack. So if I have a chance, I will take a video of THS. Okay, I think I remember I took a short video in my channel. All right, yeah. Now let's go to the canards. Canards, the canard is a small wing placed in front of the main wings. Okay, canards is a small wing placed in front of the main wing of an aircraft. Okay, so it works like a horizontal stabilizer. It also works like a horizontal stabilizer, but instead of being at a back like most planes, it at the front. Canards. Okay, so what does canards do? The canards lift the nose up. Canards lift the nose up and by creating a positive lift, just like the main wing. And in normal aircraft, the tail pushes down. Normal aircraft tail pushes down to stop the nose from being dropping. But in canard aircraft, both the canards and the main wing lift for upward to keep the plane balanced. Okay, so this idea is having two lifting wings makes the plane more efficient in theory because the less drag is created for the same amount of lift. So history and the types, the Wright brothers used the canard on their very first plane, the Wright Flyer. Modern planes, especially in military jets, like starting to use canards again. And these are two common types, like small front wing that acts like a normal tail, and also the tandem wings where the front and the back wings are mostly the same size. All right. Okay, advantages of canards. The canards can help balance the plane better when the load inside the plane changes and the fuel is used up and weight shift and the aircraft changes speed like from subsonic to supersonic. So with the help of modern computer systems, canards can actually improve maneuverability, especially in the flight in jets. And the disadvantages of the canards, like canards can cause turbulence. Canards can happen turbulence, messy air that affects the main wing, especially at certain angles. And this can make the aircraft less stable and harder to control in some situations called deep storm. Okay, and because of this, civil aircraft, passenger planes rarely use the canards. Okay, because of this reason, passenger aircraft rarely using the canards, and the canards are more common in military planes where agility and the fast maneuvers are more important than the stability. All right. Okay, these are called the canards. Okay, this tail like stabilizers we call this one situated in the front of the aircraft. Okay. All right, now let's go to the Elevons. Elevons are special control surfaces that combines the jobs of elevators and ailerons. That is called Elevons in one. So they used on fast delta wing aircraft. Normally Elevons are used mostly fast delta wing aircraft, triangular shaped wings like Concorde and which don't have a tail, stabilizer with elevators, right? So where are Elevons? Elevons are placed on the trailing edge, back edge of the main wings, one on each. Okay, so how do elevons work? When both elevons work together, up and down, they act like an elevator and make the plane pitch up or down. When one elevator moves up and the other moves down, they act like a ailerons. Okay, they make the airplanes roll, tilt to the side. So elevons can also do both action at the same time. So depending on how the pilot moves and control. For example, one element goes fully down and the other goes partly down. The plane rolls and pitches at the same time. Okay, just remember it. How are they controlled? The pilot still use separate controls, stick or pitch and roll, and these controls are combined mixed by mechanical and electronic mixture to move the ailerons correctly. And so even though the plane doesn't have separate ailerons and elevators, it still flies the same way. So why use elevons? Elevons are ideal for delta wing aircraft and they don't have space for tail and elevators, and they help reduce weight and drag and allow simple, fast and stable flight at high speed. Okay, just remember these are called the elevons. So this one stick neutral and this one you can see stick aft and stick forward. Okay, stick right. This one act as a aileron. Okay, stick left act as a aileron. Okay, like this. Now let's go to the rudder. Yeah, the rudder is movable surface attached to the vertical stabilizer. Rudder is a movable surface attached to the vertical stabilizer. Vertical stabilizer and the upright fin at the back of the airplane, and it helps control the plane's yaw. Rudder helps to control the plane's yaw, the left or right movement of the nose, like turning the steering the wheel in a car. So how does the rudder work? The rudder is controlled using foot pedals. Okay, rudder is controlling using the foot pedals in the cockpit. They push the left pedal, the rudder moves left. The nose turn left, and push the right pedal, the rudder moves right, nose turn right. Okay, so when the rudder moves to the airflow, it pushes the tail in opposite direction, causing the nose to turn. So rudder becomes strong at high speed. As the plane goes faster, the air moves faster over the rudder. So this makes the rudder more powerful, so small movements can cause big effects. So to protect the plane, the rudder movement is called limited at high speed. Okay, this one have a component. Okay, rudder limiter. So how this rudder movement limited? Yeah, small aircraft use simple limiter that changes at a certain airspeed, and the large aircraft like Airbus and Boeing use a computer control system gradually reduce rudder deflections as a speeding. It means if the speed is increases, angle of the rudder can move is reduced. So this system was called rudder limiter on aircraft, rudder ratio on Boeing. Okay, rudder limiter for the aircraft Airbus, rudder ratio for the Boeing. So example on A320, Airbus A320, at low speed, rudder can move 25 degrees. At the top speed, 380 knots, the rudder only move 3.5 degrees, even if the pedals are pushed fully. Okay. So what is the computer fails? What if the computer fails? If the rudder computer stops working, the system goes to fail safe mode. So in this mode, the rudder acts as if the plane is flying slowly, so it can move fully. Okay, fail safe mode is aircraft that can move fully. So the pilot must then be very careful because the full rudder deflection at high speed can damage the plane. Okay, yeah, so this one you can see air deflected to the left. Okay, rudder pedal forward. Okay, you can see this picture. Yeah, okay, if something happened, the rudder moves away from the aircraft. Okay, rudder limiter configurations. If the aircraft comes to 160 knots, it suddenly drops to 3.5 degrees more than 380 knots. Okay, yeah, this is called the Boeing rudder ratio changer. Okay, rudder limiter. The Airbus rudder limiter. Okay, Airbus rudder limiter is like this. Just go through it. Okay, these systems I will going to discuss in the A320 type training and also Boeing 777 type training I'm doing. Okay, I think I need to go more. Yeah, so now let's go to the ruddervators, V-tail aircraft. So some light aircraft like the Beach Bonanza 35 or use a V-shaped tail instead of regular vertical and horizontal tail surfaces. This design is called the V-tail and the movement part of it's called the ruddervators. So what are ruddervators? Ruddervators are control surfaces that combines the job of elevators and rudders in one surface, and they are attached to the back of the V-shaped tail, two angle surfaces instead of vertical fin and horizontal stabilizer. And how do they work? The pilot controls stick and rudder pedals. are connected to the ruddervators through the mixture unit, and the mixture unit combines input from the both pitch, stick and yaw pedals. Okay, so for the pitch controls, when the pilot pulls or pushes the control stick and the both ruddervators are moved together, push up or down or raise lower the nose, just like elevators. Okay, so for your turning the control, turning your control like turning, when the pilot pressure the rudder pedals, one ruddervator moves up and the other moves down. So because they are mounted at right angle, this causes the nose to yaw, turn left to right like a rudder. Okay, so both at the same time, the mixer adjusts the position of each ruddervator to give the right combination of pitch and yaw. So advantages and disadvantages. Advantages: slightly less track. In theory, fewer parts than traditionally tail designs. So disadvantages can cause stability issue called Dutch roll. Okay, Dutch roll can happen. Side to side wobble. Okay, Dutch roll, and not much better performance than regular tail. Because of these problems, V-tails, ruddervators are not very common in most aircraft today. Okay, yeah, these are called the ruddervators. You can say up elevator down, and the down elevator tail up, and right rudder tail left. Okay, you can see this is the ruddervator operations. Let's go through it. Now let's go to the Dutch roll. The Dutch roll is a type of unsteady movements that airplanes can have during flight. Okay, Dutch roll is a type of unsteady movement that some airplanes can have during flight. So it's a mix of two motions happening out of sync. Okay, out of sync. So example, yaw. Number one, yaw, the nose swing left and right. Yawing, like nose nose swing left and right, like a fish tail or tail wagging. Rolling, the airplane rocks side to side. Airplane rock side to side, like a tilting from wing to wing. So these two movements happen together but not perfectly aligned, so the aircraft wobbles in the air. So when does dash roll happen? It usually affects aircraft with swept wing. Okay, so the swept wings that angle backward like a passenger jets. So high wing aircraft and those with dihedral wings angle upwards can also experience this, and it can become worse at high altitude and low speed. Remember, Dutch roll can be worse in at a high altitude and low speed. So is Dutch roll dangerous? In most small aircraft, Dutch roll is usually not big problem. It is natural, damped, slow down on its own. In large or fast aircraft, Dutch roll can become stronger and needs to be controlled. So how is Dutch roll controlled? To prevent or reduce Dutch roll, modern aircraft use a yaw damper. Okay, modern aircraft, they use yaw damper, a computer control system that moves the rudder slightly and quickly to cancel the yaw. So side to side movements before it causes rolling. Okay, there can be a questions which using to control the Dutch roll. What is this yaw damper? Yaw damper. Okay. Right, so what affects the Dutch roll? Some aircraft designs features increased Dutch roll, swept wing, angle backwards, and wing mounted high. Okay, some aircraft design features increases Dutch roll. Aircraft design features increases Dutch roll. What are these designs? Swept wing, angle backwards, and the wing mounted high above the center of mass, and dihedral wings. Okay, these increase the Dutch roll effect. So to help control these, designers may add slight downward angles like anhedral to the wings in high wing aircraft, and install yaw dampers in large jets. Okay, so this is called the Dutch roll. Okay, yaw and roll. Okay. And to overcome this one, we use the yaw dampers. Okay. All right. Yeah, that is the end of this lesson. Thank you for participating. I think this is very long lesson. That's why module 11 is very long. If you still not watch, subscribe Kwiation Engineering YouTube channel. Please subscribe. Please share these videos with your friends, relatives, anyone who like to learn about aircraft maintenance, especially for the EASA examination. Yeah, so from today I started module 11. In future, I will do more videos regarding module 11. So I will try to finish module 11 as soon as possible. And also I already finished module 1 mathematics. I still continuing aerodynamics and also gas turbine. All right. Okay. So we will meet on another lesson. Have a good day for all of you.